Well, hello and welcome to another episode of Rustam Shah Live with me, your host, Rustam Shah. And today I have my guest, Dr. Abraham, or commonly known as Avi Loeb, who is an American theoretical physicist who works on astrophysics and cosmology. Dr. Loeb is the Frank B. Baird Jr. Professor of Science at Harvard University, founding director of Harvard's Black Hole Initiative, and director of the Institute for Theory and Computation within the Howard Smithsonian Center for Astrophysics. Dr. Loeb is a fellow of the American Academy of Arts and Science and American Physical Society and the International Academy of Astronautics. I mean, there's a long list of achievements, but let me first introduce and welcome Dr. Loeb. Thank you very much. I know you're a pretty busy person, but thank you very much for joining. It's an honor, sir.
My pleasure. Thank you for having me.
Let me start by quoting you a line which I read recently, and I like that, and I think you will like that too. It says, scientific knowledge is an island in an ocean of ignorance. Now, when you wake up in the morning, the way you do your science is slightly different than, let's say, the so called establishment. So, what motivates you when you wake up in the morning and you said, okay, let's go and do some science, which is quite interesting and quite a people like you nowadays.
Well, I'm trying to figure out the world that we live in without prejudice, without being too much attached to my own ego. And that's the way that kids approach the world. And we could have saved time if you were to introduce me as a farm boy, because I grew up on a farm. I was very connected to nature as a result. And I still try to maintain my childhood curiosity in the way that I do my science. And just to give you an example, yesterday I woke up at 4:30 in the morning. I usually jog at sunrise. Every day is different at sunrise. And I enjoy jogging because I'm surrounded by nature, by birds, by ducks, wild turkeys, and so forth. And I really enjoy interacting with nature and learning about it. The other thing is that I approach questions just like a kid. I don't pretend that I know more than I actually know. Just to give you an example, I work on the universe at large, and you very often hear cosmologists bragging about how much we know about the universe since the Big Bang. But if you look at it, it's all accounting. We know that 95% of the stuff out there in the universe, the constituents of the universe, cannot be found in the solar system. It's not something that we are familiar with. It's not the material that we are made of. We call it dark matter. We call it dark energy. And the words dark is just a label to hide our ignorance. It's invisible to us. We don't know what it is. It's stuff that we don't find in the solar system. So saying that we understand the universe is really an oxymoron when you deal with dark things. It's just that we don't understand 95% of the universe. How can we claim that we understand it? All we know is the accounting. We know that 80% of that is of that type, 20% of a different, but we don't know what the nature of those dark components is. So that's why I'm saying that even the Nobel Prize in Physics yesterday was awarded to 3 people who pioneered experiments on quantum entanglement, which is a facet of quantum mechanics that is a century old. Okay, and when quantum mechanics was discovered, in part thanks to Albert Einstein had a problem with it. He said, something is wrong. It cannot be right. There cannot be a spooky action at a distance. These guys went out and experimented and found that Einstein was wrong. Okay, so again, what does it show us? That we should be humble because there is a lot we don't know. And those people who got the Nobel Prize in Physics yesterday, they would argue that they don't understand quantum mechanics. We cannot really figure it out. We don't know what it means. It's really very strange. That's why Albert Einstein resisted the notion of action at a distance, and they found it experimentally. So even though we know it exists, that the quantum world operates in ways that we don't fully understand, we don't really have a deep understanding of the meaning of it. And what I'm trying to say is that we don't understand a lot, but we often forget about it. And we are, as a matter of our ego, we are getting pride of the little that we know. And the problem with that is, if you see something new, then very often you would try to explain it based on what you know as an expert, because that's where your prestige, that's where your self-esteem comes from, that's where your stature, professional stature comes from. And then if it doesn't agree, if the evidence doesn't agree with what we know, you will try to brush it under the rug. You will claim, oh, maybe the measurements were not correct, let's forget about it, let's move on. And that's the wrong attitude. If we were humble, if we are just saying, forget about our ego, there is something unusual going on out there, we don't understand a lot, let's be open-minded, let's not worry about the risk to our stature, our ego, our ability to gain honors or awards. Let's just collect as much evidence as possible and let nature guide us. So the important thing is to give up on our ego as the priority, but and rely on what nature tells us, and that is evidence. And that is a new idea that Galileo Galilei promoted about 4 centuries ago. And in particular, he applied it in the context of the fact that the Earth moves around the sun, and people didn't like that notion, put him in house arrest. Today, they would have canceled him on social media. And that didn't matter much, because if you were to ask those philosophers at the time to design a space mission that would reach Mars, they would never get to the destination, because they thought that Mars moves around the Earth. So my point is, we should be humble. Reality is whatever it is. We shouldn't rely on our intuition or our prejudice. We should just let nature guide us. And that's what I do every day. And just to give an example, yesterday at 4:30, when I woke up, I looked at a paper that was posted a month ago by astronomers in Ukraine, claiming they see unidentified objects in the sky. I thought to myself, when I noticed that paper, I thought that's the worst place to look for unidentified objects, because there are lots of things flying in the sky when you have the military zone. Yeah. But yesterday morning, I decided to look into it. And then what did I figure out? That they made a mistake in the estimates of these unidentified objects. And in fact, if you correct their mistake, you can easily explain those objects as artillery shells. So these are the kinds of things you expect to be flying over Kiev. And these astronomers were saying, oh, no, we see something really unusual. But when I checked it, I got this pleasure of figuring it out. This was the title of a book that Richard Feynman wrote, The Pleasure of Finding Things Out, which is really the pleasure of doing science, doing physics, trying to understand things from first principles, and not worrying about our ego.
Okay, you're also famous, and not famous, but you are the authority on the oumuamua, which is the first interstellar object detecting passing through the solar system. Now, after that much research you have done for years, I mean, you are doing this for last, like, 5-6 years, more than that. So if you have to describe what the oumuamua was, because there are so many stories out there, how would you describe to a layman, or not a layman, but let's say, if you say, okay, this is my theory, and I think this is what it was?
Well, we know what it's not, okay? It's not a rock of the type that we find in the solar system, because it, as it was tumbling every 8 hours, the amount of sunlight reflected from it changed by a factor of 10. And that meant that it has a very extreme shape. For the rocks that we find in the solar system, at most, the amount of light reflected is changed by a factor of 3. And then the best fit to the variation of light was that of a flat object, not cigar shape. And the flat object is unusual. And then it was pushed away from the sun. So if it was sunlight that was pushing it, it must have been very thin. So what is clear is that the object is not the type of rocks you find in the solar system. And everyone agrees to that. Everyone that looked at the anomalies, the unusual properties, the mainstream astronomers that tried to explain it, they said, yes, it's not a rock that we are familiar with, but it's a rock of a type that we've never seen before, like a hydrogen iceberg, a nitrogen iceberg, or a dust bunny, a collection of dust particles loosely held together. All of these proposals by mainstream astronomers that try to account for some of the anomalies of Oumuamua, all of them invoked something that we've never seen before. Okay, so I say, I completely agree with you. It's something we've never seen before. We should leave on the table the possibility that it's artificial. Because if you imagine a cave dweller that is used to playing with rocks all of his life, finding a cell phone, the cave dweller would argue the cell phone is a rock of a type that I've never seen before. It's very shiny. But then if the cave dweller would press a button, he would realize that it records his voice. Another button would record his image, and then it will become clear that it's not a rock. So what I'm saying is we need to get more data, and a picture is worth 1,000 words. And, obviously, if I had a photo album of Oumuamua, I would never write my book, Extraterrestrial. It would just be a waste of words, 66,000 words. I would just show the images. So I established the Galileo Project a year ago, and one of the goals of it is to get an image, a high-resolution image, of the next Oumuamua, and we have a dating app to find it, which is the Vera Rubin Observatory in Chile, that will start operations in a year, and then provide us with candidates like Oumuamua every few months. So then we can follow on them and send a space mission that will pass close to them.
Okay, so
Yeah.
sorry, you mentioned that we actually bumped into this Oumuamua, not the other way around, and it is difficult to understand sometimes. Can you explain this? And also, you also mentioned somewhere that it is quite possible, just like we throw sometimes trash out of our driving while we're driving and throw trash, and it hope that this plastic goes somewhere. It
Right.
could be like a cosmic trash. What do you mean by that, sir?
Yeah, so let me answer the second question first. So in 2020, September 2020, which was about 3 years after Oumuamua was discovered, the same telescope in Hawaii, Pan-STARRS, discovered another object that shared the qualities of Oumuamua. It was pushed away from the sun by reflecting sunlight, and it had no cometary tail. There was no cometary evaporation, no gases or any dust around it as a result of the illumination by the sun. And within a few weeks after that discovery, they realized this object from 2020, which is given the name 2020 SO, is actually a rocket booster from a 1966 launch by NASA. And so we know that it's artificial because we made it. It had very thin walls, and that's why it had a large area for its mass. So it was pushed by reflecting sunlight. So that's what I mean by space trash. That something that happened to be a piece of another object. In this case, it was just a rocket booster, or it's something that happened to be thin for another reason, but it's artificial in origin. Okay, and if you think about the spacecraft that we launched that will exit the solar system, these are Voyager 1, Voyager 2, New Horizons, Pioneer 10 and Pioneer 11. So there are 5 of them. And within 1 billion years, they will all be space trash. They will not be functional. So now with respect to your first question, what another property of Oumuamua that was strange is that it came from a very special frame of reference, which is sort of like the local parking lot. When you look at all the stars in the vicinity of the sun, they have some random speed relative to each other. And when you average over those speeds of all the stars, or over the velocities of all the stars, you end up in the so-called local standard of rest. Just think about the center of a city where cars are moving in all directions, and you average over the motions of the cars, you end up in the frame of the city, so to speak. So that is the local standard of rest. And Oumuamua was at rest in that frame at a level that is only shared by 1 out of 500 stars. So it's a very rare thing to find, 1 out of 500 chance to find a star that is so much at rest as Oumuamua was in the local standard of rest. And the sun, of course, moves relative to that frame, and it simply bumped into it. So the way to think of this is like Oumuamua was a buoy on the surface of the ocean, and the solar system was like a giant ship. that bumped into it. So that was another unusual fact about Oumuamua that nobody explained. So all the suggestions for a hydrogen iceberg, a nitrogen iceberg, these are suggestions for objects we've never seen before that come from completely different environments than we are familiar with. And moreover, they don't account for the fact that it came from the local star of rest, because if it came from another star, the star would have been moving.
But
Yeah.
But there is one thing: we put buoys ourselves strategically. So it is also possible. I mean, I know you don't like to speculate, but if you have to speculate, that somebody placed this because they knew that the rotation of the stars, because you can calculate them to the future, you can go in the back, in the past, and you can very accurately calculate. So is it possible that this was particularly put there by something or someone?
Yeah, it's possible. And the question is why? But it's certainly the best thing to do in terms of saving energy. You just put it in the local standard of rest at the right direction from the sun. You know the direction of motion of the sun, and you just put it at the right place such that it will enter the inner solar system where life exists. That's called the habitable zone. Okay, and that's roughly the orbit of the Earth around the sun. And you just position it, and the sun is colliding with it, and you don't need to propel it. You don't need to launch it in the direction of the sun. The sun will just run into it. So that could be designed in advance to save energy. Or you can imagine another possibility, that there are lots of these objects that are placed on a grid in the local standard of rest, and that is used like signposts, road posts. If there are systems that navigate through interstellar space and they need to know where they are, there is this grid of buoys that tells them where they are.
So it is quite okay. So there is one possibility among many that maybe some ancient civilization. One of my friend asked also that is it possible that this could be like a seeding mission, because as you mentioned, it must be very thin. I mean, you said something like millimeter thin. So in that thickness, it's very difficult to put to instrument, let's say, if they are designed to go and find something, but you can put some biological material in it, the panspermia. Is it possible that these kinds of things are just put there just to seed the so-called life? I know it's
Yeah.
speculating.
No, this is a very interesting possibility. Now you have to keep in mind the transverse size of the object was roughly a football field size, like 100, 200 meters. So think of it as a sail, basically, as something very thin but large. And the question is, what would be the purpose of such a thing? And you can think of two things. One is spying on the habitable zone, trying to figure out what's happening. When this thing passes through the habitable zone, it's targeting that region to figure out what is out there. It could also be a mother ship that releases seeds, like dandelion seeds, like releases smaller spacecraft that we can't see. With our survey telescope in Hawaii, we could only see objects bigger than the size of a football field within the orbit of the Earth around the sun. So all the smaller things we can't see. So it's possible that many more smaller things may be released by this mother. And what you said is really interesting. It's also a possibility that if you want to bring some particular forms of life or self-replicating machines, it doesn't need to be biological. It could, we think of life as a chemical path to replicating DNA or other, basically living organisms. And we are almost getting to the point where we can produce self-replicating robots that use 3D printers to make copies of themselves, and if they're equipped with artificial intelligence, we might get it not from biology. We might get mechanical objects that are doing exactly what biology does, within a decade or two. And it doesn't really matter what is the mechanism that you're using, whether chemistry or mechanical, to reproduce. The point is that this would be a way to multiply the number of elements that you have in your family of objects. And so if there was another civilization that existed a billion years ago, and by the way, most stars formed a billion years before the sun. So it's easy to imagine that there was another civilization where the clock started ticking a billion years before our clock. Okay, so they are already a billion years beyond us in terms of technological development. And they sent probes to interstellar space. And within a billion years, such probes, even if they move, if they are propelled by chemical fuel, like we send all of our space missions, they can traverse the Milky Way galaxy in 500 million years. And if they land on planets, they can easily self-replicate from whatever they find, all the resources, the fuel that they find on the planet. So you can imagine them basically figuring out how to replicate and fill up the Milky Way galaxy within a billion years. And that could be one of the goals, to produce more of the same. And if they have artificial intelligence, they would then use machine learning to adapt to new circumstances and so forth. So whether we live in such a reality or not is not a philosophical debate that we should engage in. And a lot of people have opinions. That's not the issue. It's not having an opinion. Again, we don't know whether we live in such a reality or not. And the only way to find out is by collecting evidence. And if the first object that was reported, like oumuamua, happens to be weird, we should pay special attention and get more evidence. Try to look for smaller objects. Try to get close to it and get a high-resolution image of it. That's the way we will learn about reality. Not by saying, forget about it, it's a rock of a type that we've never seen before, ridiculing it and moving on, which is pretty much, when oumuamua was discovered, half a year later, there was a group of mainstream astronomers that wrote a review paper for a very prestigious journal, Nature Astronomy, and they basically said, it's a natural object. That's it, exclamation mark. Forget about it, let's move on. And then a few months later, other astronomers paid attention to the anomalies and tried to explain them. And they said, maybe it's a hydrogen iceberg. And then a few months later, another group said, oh, maybe it's a nitrogen iceberg. And then maybe it's a dust bunny. So my point is, it wasn't obvious that it's natural if all these other groups had to work very hard and produce scientific papers on different hypotheses of things that we've never seen before. How is it possible that the group of, or I should call them the herd of experts, came together and announced it to be natural, exclamation mark, before the other groups came up with specific explanations? It's not honest.
We also have, recently learned that the universe has just got bigger for us, because we discovered that we are not the only planet. There could be billions, if not trillions, exoplanets, and a small percentage of these planets would be, in the so-called Goldilocks zone where life could exist. Now, you mentioned previously that we have the James Webb Telescope now. We can look through the atmosphere of some of these exoplanets. But you suggested that we should also look the industrial pollution. Why not biosignatures, which we can detect? Why industrial pollution, sir?
Well, so the biosignature, that, by the way, that's the focus of the mainstream in astronomy in terms of future telescopes. That's how they are motivated, basically looking for oxygen or methane or other gases, CO2, water, as indicators that life may exist on a planet. Okay, so when a planet transits a star, you can find the fingerprints of these molecules in the atmosphere of the planet from the light that goes through that atmosphere by analyzing it. The issue is that Earth, if you just look at Earth, the one example that we know about, okay? So even that example is completely inconclusive, because for the first 2 billion years, there was not much oxygen in the atmosphere. So for half of its life, Earth didn't have a lot of oxygen. So if you were to catch, there is a 50% chance that if you look at another Earth, exactly a copy of the Earth that we have, you would find no oxygen in the atmosphere. So if you don't find oxygen, you cannot conclude that there is no life, because there was microbial life on Earth. It was the cyanobacteria that produced the oxygen in the atmosphere after 2 billion years, and it did it suddenly.
Yeah.
And by the way, I should say, I just noticed that it did it about 2.5 billion years ago. And that happens to be exactly the same time when Mars lost its atmosphere. So there was at the same time good news and bad news in the solar system about concerning life. Mars lost its atmosphere. All the oceans evaporated on Mars. We know that there was it was very likely that there were that it was rippled with ponds and the rivers. We see evidence for that. But then 2.5 billion years ago, poof, the atmosphere went up. We don't know why. But what I'm saying is there is this interesting coincidence that I noticed. When Mars lost its atmosphere, that's when Earth suddenly, in a very rapid transition, had cyanobacteria that produced a lot of oxygen. I don't know if there is a causal link between the two events, but it's just interesting. And the point is, if you find another Earth, it may not have cyanobacteria that produces that oxygen. So you can't tell. If you don't see oxygen, you can't say there is no primitive life, no bacteria, no single cell organisms on that planet. And if you do find oxygen, in principle, you can make it by natural processes as well. So what my point is, it will not be conclusive. And you can see that already from the debate about Venus. There was a claimed detection of phosphine, and then the detection was disputed. So irrespective whether there is a detection or not detection, the interpretation of phosphine was in question, whether it means that there is life or not life. So these are the kinds of debates that you will have even after investing billions of dollars in building these instruments, these telescopes, future telescopes that the astronomy community is advocating for. And my point is, if instead of looking for oxygen, just think about it, if you look for industrial pollution and you find it, these are molecules, for example, that refrigerating systems that industries produce on Earth. Yeah. They cannot be produced naturally. They are big molecules, very complex molecules. Nature doesn't put them together. It's coming from our industries. So if we find those, not only that we know that life exists on that planet, but we also know that in industries that it's a technological civilization. So that is for sure, because nature doesn't make such molecules like CFCs. And you might say, oh, maybe it shows that the civilization is not very intelligent because they are going through global warming, and everyone, nowadays everyone says global warming is a risk, existential risk. Well, don't think about it this way, because imagine a planet that is a little too far from the star. It's too cold, it's frozen. And if a civilization wants to terraform it and make it habitable, they would pollute the atmosphere there such that it would get warmer. It's sort of like putting a blanket on your body when it's too cold. So they might put artificial, industrial pollution in the atmosphere. It could be good for them to be on a planet that is industrially polluted, just because it's like a blanket that keeps them warm.
So so the idea itself is that we should not ignore the things which we are, think for us is bad, so it may be good for someone else. Yeah, you're right.
Yeah, I mean, if you think about planets, they may occupy any orbit. We happen to be in the habitable zone with the Earth, and that's why we worry about global warming. But if we were a little bit out, when Earth would be very cold, very cold, and then we would like to be warmer.
Okay, so I know you are the authority on the oumuamua, but the oumuamua, we just understand, is not the only object. You also recently discovered the so-called IM1 and IM2s. So please tell us about these two objects, because one of them is actually predated the Oumuamua, actually.
Both of them, both of them.
Both of
So
them.
yeah, I should say. So what happened was that after a couple of years, a year and a half after Oumuamua, I was asked to appear on a radio interview about a meteor, and I read about meteors, and I realized there is actually a catalog that was compiled by the US government under NASA, which is based on data collected by missile warning systems. So the US monitors the atmosphere for ballistic missiles, and of course, every now and then they see a rock entering the atmosphere from space. And the reason is that the Earth moves around the sun, and as it moves around the sun, it collides every now and then with a rock. And most of these rocks are from the solar system. And, the dinosaurs were killed by a giant rock the size of a city. And it actually created a tsunami in the ocean. There was a huge wave that was. Anyway, so the government sees these meteors, and we can easily see them because even if they are the size of a person, they release, as a result of the friction with the atmosphere, they burn up and they release an amount of energy comparable to the Hiroshima bomb, atomic bomb. So that's a huge fireball created as they burn up in the atmosphere. You can easily see it from a distance. So anyway, there is this catalog, okay, the government compiles, and it has 273 meteors in it, starting from a decade ago. And so knowing about Oumuamua, I asked my student, Amir Siraj, to check the catalog because the government records the speed of these meteors, the velocity. And I asked him, check the fastest moving meteors. Perhaps they came from outside the solar system. If we go back in time, we can figure out if they are bound to the sun or not. And indeed, we found one from January 8th, 2014, that landed about 100 miles off the coast of Papua New Guinea and exploded about 18.7 kilometers above the ocean level. And it released a few percent of the Hiroshima bomb energy in that explosion. So from that, you can figure out that it was roughly the size of a basketball, a half a meter or so in diameter. And so we said, this is the first interstellar object ever discovered, because it was almost 4 years before Oumuamua was reported.
Yeah.
So we wrote a paper about it, showing the calculations that indicate that it's interstellar beyond any reasonable doubt. In fact, it was moving faster than 95% of all the stars in the vicinity of the sun. So it was faster than 95% of the star. And then our paper was not accepted for publication in the Astrophysical Journal because the reviewers said, we don't believe the US government. We don't have the uncertainties in the measurements. And to me, it was obvious the uncertainties are small because the US government needs to know whether a ballistic missile will hit Boston or New York City. They can't afford to be wrong. Anyway, it took 3 years, and in March 2022, about half a year ago, the US Space Command released a letter to NASA that basically said that they confirmed the conclusion of my student and me in our paper that that this object came from outside the solar system at the 99.999% confidence.
But you also,
sorry,
you mentioned that not only that it was pretty fast, but the thickness, the strength of this particular object was more than what you normally see in the nature.
That's right. Wait, so first of all, our paper is now accepted for publication, thanks to the government letter. And secondly, and despite the skepticism from people who worked on rocks for decades, okay, here again, I'm saying, you could be an expert on rocks in the solar system, but this is a rock that came from outside the solar system. Just, let the evidence tell us what this thing is.
Yes.
Because the government also released data about the fireball, the light curve of the fireball, how much light was produced over time as it exploded. So we used that data to find out that the object actually was tougher than iron. It was tougher than all other objects in the meteor catalog that is called the CNEOS. That makes it an outlier at the level of 99.7%. All other space rocks are less tough. They have material strength weaker than this meteor. So why would the first interstellar meteor be tougher than all other space rocks? It's certainly not drawn from the same population of objects.
Yeah.
And then we found just a few weeks ago another interstellar meteor in the same catalog, and it was number 3 in material strength. So out of the population of all the meteors that was cataloged by the government, the chance of the first 2 interstellar meteor, and the second one was from March 2017, so half a year before Oumuamua, both of them are meter size. And so the second one and the first one, the probability of drawing the 2 of them in material strength from the rest of the catalog is 1 part in 10,000. So they clearly originate from a source that is very different than the solar system. And the question is, what is that source? Now, it could be natural. It could be that such objects, interstellar objects, are ejected from an exploding star.
Under high pressure, it could be possible.
It's possible, and that's why they are tougher. But it's also possible that they're artificial. That it's a spacecraft that was moving faster than all the stars, and it's made of some alloy that is artificial, and that's why it's tougher than iron. So I'm saying again, don't argue with me. It's not a philosophical argument. We will find it out because we are planning an expedition to Papua New Guinea to collect the fragments of the first interstellar meteor. And so I announced this expedition a few months ago. We have a very qualified team of experts that are used to such expeditions. And moreover, I received all the funding that we need, $1.5 million from people that came to me and said, we are happy to fund your expedition. Let's find out. So we will scoop the ocean floor and see what kind of fragments we find. And from that, we will figure out the composition of this. Yeah.
But the size of this particular object, because it burned and entered, it must be very small. So do you think that the ocean is pretty big place and you're literally looking for a needle in a haystack?
Okay, so when an iron meteorite, an object made of material that is mostly iron, explodes like that, what happens is you end up with a lot of fragments. You end up with iron rain, droplets, tiny droplets, the size of the head of a needle. And I wouldn't advise anyone to use an umbrella to protect yourself from such a rain, because these droplets are, very hot. They will go through your umbrella. So they fall on the ocean and sink to the bottom. And that's what you expect from an iron meteorite. You have basically a large collection of droplets. So if you scoop the ocean floor, you might find them. And we don't need more than a few grams of material, in order to figure out the composition. And by the way, even if it's natural in origin, we could demonstrate that it came from outside the solar system, because the isotope ratio would be different than you find for rocks in the solar system. But if it's artificial, we would see that it's made of elements that nature doesn't put together. And that's the goal of the expedition. Now, of course, if we find something big, I already promised the curator of the Museum of Modern Art that I'll bring it for exhibit, because if it's a piece of technology, we would regard it as modern art. Of course, whoever sent it would regard it as ancient history.
Yes, that will be interesting if you can find a piece. But it's really interesting because we thought, at least I thought, that the oumuamua was unusual. But as the technology is advancing, it seems that these objects are pretty, perhaps, common. We may find them because you had this sensors from US government, basically.
Yeah.
Okay, so they were classified. So I understand they will not share the data with everybody. But it's quite possible we may find more of them.
Yeah, so the point is the detection method is different for the meteors and the oumuamua, because For oumuamua, it was the reflection of sunlight from it. That's why we cannot see objects much smaller than 100 meters, because they don't reflect enough sunlight for our telescopes to pick them up. But the meteors were discovered because they burned up in the air, in the atmosphere. So then they generate their own light, and you can see an object as small as a meter, because it burns up, produces a lot of light. And so these are different size objects, and for every oumuamua, there should be about 1 million meteors that are roughly a meter in size. So there should be many, many more of them. And the question is, what are they? And my point is, we should be guided by evidence, not by prejudice. We should not claim that they are a rock of a type that we've never seen before. And I should say also that the first 3 interstellar objects appear to be weird. The first 2 meteors are tougher than iron. Why would they be so unusual? The first interstellar object that is not colliding with the Earth appears to have these anomalies, oumuamua, that I mentioned before. And then there was a 4th object that was discovered by an amateur astronomer, Gennady Borisov, and that looked like a comet, a very regular, usual, familiar comet. So I would say, out of the 4 interstellar objects, and just over the past decade, we were starting to see interstellar objects. So before that, we never had the technology to find them. And out of the 4 that we know, 3 are unusual. So just like with dark matter, I would say the verdict is out as to their nature. Let's not assume that what we find from outside the solar system is the same as what we have in the solar system. In the context of dark matter, that's definitely not the case. We know that dark matter is of very different stuff, made of material that we don't find in the solar system. So when we see these interstellar objects coming in and appearing to be, in 3 out of 4 cases, to have properties that are not shared by the rocks that we're familiar with, let's be open-minded about it.
You are also heading the project, Galileo Project also.
Right.
And it was started roughly a year ago. So what work have you done so far, and what is the current status of this Galileo Project?
Yeah, so the Galileo Project was inspired by a few wealthy individuals that came to the porch of my home and decided to give me a few $1 million because they read my book, Extraterrestrial, and were excited by the vision of the book. And so they just gave me money without me doing any fundraising. And it was around the time when the US government, specifically the Director of National Intelligence, Avril Haines, delivered a report to the US Congress in which she talked about these unidentified objects and the fact that the government is not sure what to make of them. And so a month later, we established the Galileo Project using the funding that I received. And now it involves about 100 people, and we have a waiting list of 800 people who want to join us. And basically, we are pursuing a 3-facet research program. One is to, as I mentioned before, to develop a space mission that will come close to the next oumuamua. The second that I also mentioned before is the expedition to find the composition of interstellar meteors. And the third one is to identify the unidentified, to figure out what these objects that the Director of National Intelligence was speaking about, what are they? To basically help the US government figure out the nature of UAP, unidentified aerial phenomena. And so what I wrote yesterday, this paper about the UAP in Ukraine, that's an example where what some people call UAP could have mundane explanations. They could be just artillery shells. So I'm sure it's a mixed bag, that some UAPs are, of human-made origin. Some may be natural. They could be bugs or birds or whatever. And then the question is there something else? And so we are building a suite of instruments that will collect data, take a video of the sky in the infrared, in the optical, in the radio, and in audio. And then we will use artificial intelligence algorithms to analyze the data and figure out whether we see anything that is not human-made, not a drone or an airplane,
Yeah.
uh, not artillery shells, and not natural, not a bird, not a meteor that is a rock, something else. Is there something else?
So, so we can expect some kind of results or initial results in coming months or years. You have any time period in?
Yeah, so basically, the Galileo Project is the first fully funded scientific research program to collect new data, not data that was obtained by the US government that is mostly classified. Okay, we can't access that. And it cannot be subject to open review by the scientific community because it's classified. By the way, it's classified not so much because of of the data itself, it's because the sensors that were used to collect it are classified. So that's why the data is classified. So it's the first time that there is an open data scientific research program that is fully funded to figure out the nature of these UAP. And let's see, I mean, we are completely agnostic. We will use the scientific method, which is based on evidence, and also we will use our understanding of physics, so that the example I would bring is the one from yesterday morning where, I was using known physics. So some people, the one thing I realize now from the experience yesterday is there is a community of people that say, well, there are these UAP, but they violate what we know about physics. They bring new physics. My point is, these objects that were reported by the Ukrainian astronomers, as an example, they were using the Ukrainian astronomers were using telescopes. Okay, so they use to find them. So they see dark objects. They call them phantom objects. The fact that they are dark means that they are blocking light from the background illumination by the sky. Okay, so they see them as dark silhouettes. My point is simple. If they block light, they must have electromagnetic interactions because light is all about electromagnetism. So I don't care about their nature. All I'm saying is if they block light, they also interact with the molecules of air, because electromagnetism, you can't just allow electromagnetism to help you block light. And at the same time, you cannot use electromagnetism to interact with air molecules. That is not logical. Okay, so as long as you restrict your attention to logic, you must say that if these objects are dark because they block light behind them, then they must also collide with air molecules. And therefore, they must create a bow shock and a fireball around them if they move too fast, just like meteors do. Okay, and so you can't escape that conclusion unless you give up on logic, unless you say, I believe that these objects can move through air without pushing it. I believe they can do that and remain dark and block light. You can believe in anything you want, but it's not logical. And my point is, the scientific method helps you clarify things, because if I say they push against the air, then I can infer that these astronomers made a mistake in their distance estimate, because otherwise there would be a fireball around these objects that would be a terawatt in energy per unit time. That is roughly the electricity consumption across the entire globe, So you would see a huge fireball. You cannot say that these objects would be dark. That makes no sense. Therefore, there was a mistake in the distance. And if you bring the distance down, I showed in my paper that I wrote about it, within a few hours. I just looked at that paper. Within a few hours, I wrote my own paper saying, if that the amount of power released in the fireball, I know it from meteors as well, it scales with distance to the fifth power. So if you make the distance 10 times smaller, you end up with a very reasonable amount of light that would make these objects dark. And therefore, you wouldn't see them. And so they made a mistake in the distance, and then you don't have a problem with the fireball. And then if you correct their numbers for the reduced distance by a factor of 10, you get the size of the object being a meter, a fraction of a meter. You get the speed being 1.5 kilometers per second, 10 times smaller than they talked about. And that is exactly the parameters of artillery shells.
Yes.
So everything falls into place. So that's the beauty of physics.
Okay. In the end, you met with Miss Haynes. impressions from her that she knows more than what what the US government let about the existence of these objects?
I have great respect for Avril Haines. She has a bachelor's degree in physics, so she knows theoretical physics. And when I met her in the green room of the Washington National Cathedral, it was a public event with Jeff Bezos and Bill Nelson. I asked her, I said, Avril, you just released a report half a year ago. That was, I met her in November 10th, 2021. I said, what's your gut feeling? What are these UAP? And she said, I don't know. And I believe her. So I think for us to figure it out, we just need scientific data, because the anecdotal data that the government has may not be sufficient quality to figure out these objects. And let's just allow nature to guide us. And whatever we find would be of great interest to the government, to the public, and it should be of interest to the scientific community. That's why I am interested in it. And if it ends up having a mundane explanation, like the Ukrainian UAP being artillery shells, so be it. We will clear up this subject and move on. That will be fine. But you can't clear up a subject just by claiming that, just by believing something, claiming that oumuamua is natural and moving on. That is not the right procedure. You have to collect evidence that demonstrates that it's a nitrogen iceberg, that demonstrates that it's a hydrogen iceberg, that demonstrates that it's a dust bunny before you declare it natural.
Okay, we are almost at the end of our time. I think we already finished, but can I have one more question? Last question, sir.
Yes.
I recently spoke with Dr. Michael Masters, and he's a biological, he's an anthropologist. He has Ph.D. in anthropology. And he suggested, according to him, the human evolution, because our ancestors were kind of, like us, humanoid. And he projected the same evolution in the future. And he think that the aliens that people see, they kind of look like us, humanoid. They have, 2 eyes, small noses. So, but he suggested that there may be the future humans coming back through time. Now, because you are a physicist, I think it's a good way to ask you: is it possible that in the future we may be able to travel through time? Because even if we want to go through travel in this space, this would be an important factor for us as well. So
yeah, so the problem with time travel is that you can easily get into a logical inconsistency. Just think about the following situation: that you go back in time and you create you have a car crash and your parents die in it. Okay, so then you would never be born. So there is a logic. So how can you kill your parents if you were never born? There is a logical inconsistency. So anything that happens in the past must be consistent with your existence, and you can't go back in time. So one possibility that people raise is, okay, if you go back in time and you start driving a car with your parents in it, then you will not be able to make the mistake of crashing the car. It will not. If you try to steer the wheel in a direction that will cause the car crash, it will resist it. So somehow the laws of physics protect and make reality consistent, so that your parents will conceive you later on, and the entire story will be consistent. You drove the car that never crashed, that allowed your parents to get married and give birth to you. Okay, that is a possibility, but I find it very peculiar. And the most conservative approach is to say you can't go back in time because you will create
a kind of paradox.
Paradoxes, yeah. And practically speaking, from an engineering perspective, we don't have any clue as to whether it's possible to do it, because all the ideas that physicists had for warping space-time, according to Einstein's theory of general relativity, space and time can be, in principle, modified by matter. And so people try to think about circumstances under which you will build a time machine and go back in time. And in all cases, they ended up with problems, that these space times that they thought about were not stable for a long enough time for you to go through the wormhole or to do something strange. And it's possible that when you add quantum mechanics to the mix, you might be able, but so far we don't have even a concept of a situation that would bring us back in time. So I would say let's leave that option, in the back burner for now. Don't worry about it. I think that it's much better for us to try and make our life as long as possible, maybe live forever. That is possible because in principle, when we understand how the human body works, we could design how to repair it in a way that will allow us to live forever. So you will not need to go back in time. You could just live forever.
We can talk for hours, but unfortunately our time is up. And Professor Avi Loeb, it's a pleasure because every time we speak with you or I heard you speaking, I learned so much thing. And thank you very much for your effort. And the way, that's why I asked you early that the motivation you have, because I see a lot of new generation sees you as, because you make science interesting. It's not boring anymore. So there is something to learn. So thank you very much for your time and your patience, sir.
Thank you for having me. It's a pleasure.
Thank you. Good day.
Bye-bye.
Bye. Okay, gents, that was Professor Avi Loeb from Harvard University. And that was interesting talk. Unfortunately, we had only 1 hour. I said 1 hour because we can go on and on. I had so many questions for him, but I had to go through and just sift and say, okay, let me do this and do that. Because Avi Loeb, he's a professor. So when he speaks like a professor. But so that was Avi Loeb. I hope you liked the show. I will try to get more and more people on my show as possibility arise. There are a few others shows that I have planned. चले मैं उर्दू में आ जाता हूँ. हमारे दोस्त सारे वो मेरे ख्याल में Avi Loeb चले गए तो हम उर्दू में आ जाते हैं ताकि उनको भी समझ में आ जाए. अगेन मैंने ये लास्ट टाइम पे भी कहा था पिछले हफ्ते जब मैं डॉक्टर मास्टर से बात कर रहा था कि इस तरह के मुख्तलिफ किस्म की जो ख्यालात की जो लोग हैं उनको ला कर बिठाने से आपको जो है एक नई चीज़ सुनने को मिलती है. हो सकता है आप उससे एग्री ना करते हो सकता है प्रोफेसर आवी लोब की जो बातें आपने सुनी आपको आई डोंट नो बट मतलब एक ऐसा आदमी जो PhD है जिसने और बहुत सारा काम किया. मैं इनका अगर आप रेज्यूमे देखें तो इट्स अ ह्यूज रेज्यूमे और ये वेरी वेल कनेक्टेड है. ऐसे नहीं है कि लोग उनको जो है मिलियंस ऑफ डॉलर्स आके दे देते हैं तो वो इस पर ट्रस्ट करते हैं. तो ये गैलीलियो प्रोजेक्ट पे भी काम कर रहे हैं. अब उसकी क्या रिजल्ट है आई डोंट नो. आई एम स्केप्टिकल ऑफ दैट. लेकिन इस तरह की जो सब्जेक्ट है उस पर बात करना जाए उससे हमें कुछ ना कुछ सीखने को मिलता है. तो मैं कोशिश करूँगा कि आइंदा भी मैं इस तरह के जो और मुख्तलिफ किस्म के सब्जेक्ट में जो लोग हैं उनसे बात करूँ. मैं कोशिश कर रहा हूँ पाकिस्तान के एक जर्नलिस्ट को लाने की. वो थोड़े से बिजी हैं तो हो सकता है जब वो फारिग हो जाए तो मैं उनको अपने शो में लेकर आऊँ और उनसे बात करूँ. तो इट विल बी अ डाइवर्स पोर्टफोलियो के जिसमें आपको मुख्तलिफ सब्जेक्ट्स के ऊपर बात करने को या सुनने को मिलेगी. तो अगर जैसे मैं हमेशा कहता हूँ कि इस शो को अगर आपने अभी तक लाइक नहीं किया तो प्लीज़ इसको लाइक कर दें, चैनल सब्सक्राइब कर दें, इस वीडियो को शेयर भी कर दें और कमेंट भी कर दें यार, क्योंकि हमेशा कुछ ही लोग जो कमेंट करते हैं आई डोंट नो वाई, क्यों मुश्किल लगता है लोगों को. 5 मिनट लगते हैं या 5 मिनट तो नहीं, खैर 1 मिनट लगता है कमेंट करने में. उसका फ़ायदा सिर्फ ये है जैसे आप जब वीडियो को लाइक करते हैं या जब उस पर कमेंट करते हैं तो होता ये है कि जो यूट्यूब की एल्गोरिथम्स है वो उसको देख रही होती है कि कौन सी वीडियो ज़्यादा वो हो रही है, डिस्कस हो रही है, तो वो सर्चेज में ऊपर आती है. तो ठीक है, हम इस्लाम के ऊपर भी बात करते हैं, हम मज़हब पे बात करते हैं, हम फ़िलासफ़ी पे बात करते हैं, हम साइंस पे भी बात करते हैं. तो जितना ज़्यादा आपका पोर्टफोलियो बड़ा होगा उतना ज़्यादा इंटरेस्टिंग होगा, लोगों को सुनने को मिलेगा. क्योंकि मैं उस दिन अपने एक दोस्त से पाकिस्तान में बात कर रहा था, तो जब मैंने उसको बताया कि मैं इसके ऊपर जाके ये बात करूँगा इससे इस मौजू पे, तो वो ऑलमोस्ट जिसे कहता है अगर मेरे सामने होता तो मेरी शक्ल देख रहा होता, अच्छा ये भी है, इस तरह की बात भी हो रही होती है दुनिया में. जी हाँ, हम अपनी जो है ना सियासत में, मज़हब में उलझे रहते हैं. इसके अलावा भी दुनिया में और गम है, सितारों से आगे जहाँ और भी है, अभी इश्क के इम्तिहान और भी. تو پلیز لائک کریں, سبسکرائب کریں, اور اگر آپ کے ذہن میں کوئی سجیشن ہے, آپ کسی اور سبجیکٹ پہ بات کرنا چاہتے ہیں, آپ کے ذہن میں کوئی آدمی یہ چاہتے ہیں کہ میں اس کو لے کر آؤں, آپ مجھے وہ کامنٹ باکس میں لکھ کے بتا سکتے ہیں کہ یار اس شخص کو بلاؤ, اس سے بات کر کے دیکھو. 2-3 میرے پاس ہے ایسے لوگ جن کو میں بلانا چاہتا ہوں. دیکھیں وقت کا تقاضا ہے کہ وہ اگر آ گئے, مل گئے دونوں ہم دونوں, تو بات ہو جائے گی. لیکن تب تک کے لیے میں آپ سب کا بہت مشکور ہوں جو آئے دیکھنے کے لیے, جنہوں نے کمنٹ کیے. میری پھر آپ سے اگلے شو تک اجازت, آپ سے ملاقات ہوگی. گڈ ڈے اینڈ گڈ نائٹ, اینڈ آئی سی یو نیکسٹ ٹائم.